We now discuss the solution of a problem from the section Real Analysis. The problem is related to divergent series. This question has appeared in the CSIR National Eligibility Test held on 16th September 2022 and this question is from the section B. The given question is, consider the series sigma n is equal to 3 to infinity a power n by, in the denominator, n power b into log n to the base e to the power c. For which values of a, b, c belongs to the set of real numbers does the series not converge? We are given 4 options. Option 1, mod a less than 1, b, c belongs to R. Option 2, a is equal to 1, b greater than 1, c belongs to R. Option 3, a is equal to 1, 1 greater than or equal to b greater than or equal to 0, c less than 1. Option 4, a is equal to minus 1, b greater than or equal to 0, c greater than 0. So we are given this series sigma n is equal to 3 to infinity a power n by n power b into log n to the base e to the power c. And we have to discuss for which values of a, b, c belongs to R does this series is not convergent. We now discuss the solution of the problem in detail. We have the given series. We call it as sigma n is equal to 3 to infinity un, where un is a power n by n power b into log n to the base e to the power c, where a, b, c belongs to R. We consider the option 1. Mod a less than 1, bc belongs to R. Under this scenario, is this series is not converged? We have to find out the options for which of the option the series is not convergent. Now, un plus 1 by un we will consider. So we have written un by un plus 1 and that is equal to a into 1 by, you see, n plus 1 by power b by n power b, that we have considered as a 1 plus 1 by n to the power b, and this is log n to the base e by log of n plus 1 to the base e to the power of c. Taking the limits on both sides, limit n tends to infinity un plus 1 by un is equal to a into limit n tends to infinity of 1 by 1 plus 1 by n to the power of b, limit n tends to infinity of log n to the base e by log of n plus 1 to the base e whole power c. And when you take the limit, this 1 plus 1 by n to the power of b, and that will become 1, and a into limit n tends to infinity of this one. So we can, the limit gets inside, and limit of this one is infinity by infinity form. So to evaluate that one, we utilize L'Hopital's rule. Limit n tends to infinity of 1 by n by 1 by n plus 1 to the power of c, and that is equal to a times limit n tends to infinity of this one, and that is the limit is 1, and the answer is a for all c belongs to R. This is for all c belongs to R. The above one for all b belongs to R. So, and now the answer is a, and there's the limit un plus 1 by un is equal to a less than 1 when mod a less than 1. Agreed. So for all values of mod a less than 1, a will be less than 1. Agreed. So we apply the ratio test. By the ratio test, the D'Alembert's ratio test, this series is convergent for all values mod a less than 1, b, c belongs to R. So we have to identify that situation under what option the series is not convergent. It is convergent. So therefore option 1 is not true. Option 1 is not true means it is not divergent. It is convergent. So let's get into option 2. A is equal to 1, B greater than 1, C belongs to R. So A is equal to 1, we put it here. So we have sigma n is equal to 3 to infinity 1 by n power b into log n to the base e to the power of c. Agreed. Agreed. B greater than 1 will imply n power b greater than n. Yes. B greater than 1 will imply n power b greater than n. And log n to the base e is always positive, to the power of c is also positive. So multiply throughout by that, and this will be, the inequality is maintained because it is positive. So now 1 by n power b log n to the base e to the power of c is less than 1 by n log n to the base e to the power of c. Agreed. Agreed. Now we have sigma n is equal to 3 to infinity 1 by n log n to the base c is convergent if c is greater than 1. This is a very well known result, and c greater than 1. So thus the series sigma n is equal to, so this is convergent using the comparison test. This is also convergent. Sigma n is equal to 3 to infinity a power n by n power b log n to the base c is convergent by comparison test if a is equal to 1, b greater than 1, we have used b greater than 1, and c greater than 1. C greater than 1. So it is convergent for these values. So for any c belongs to R, we have not shown. C greater than 1 shown. So the option 2 is not true. It is convergent. Even for any c belongs to R, it is convergent. Therefore, the option 2 is not true. Agreed. Let's get into option 4. Option 4. A is equal to -1, B greater than or equal to 0, C greater than 0. So we have this series, given series. A is -1, so it will be sigma n is equal to 3 to infinity -1 to the power of n by n power b into log n to the base e to the power c. So call it as sigma n is equal to 3 to infinity -1 to the power of n into un, and it is an alternating series where un is equal to 1 by n to the power of b into log n to the base e to the power of c. So now take the condition. We have already taken a is equal to -1, b greater than 0, c greater than 0 we have taken. So n plus 1 is always greater than n for all n belongs to natural numbers. So b greater than 0, therefore n plus 1 to the power of b greater than n power b. Agreed. And log of n plus 1 to the base e to the power of c is always greater than log of n to the base e to the power of c. Agreed. So we take this, multiply both sides by log of n plus 1 to the base c, and the inequality is maintained because it is positive. Now n power b log of n plus 1 to the power of c is greater than n power b into log n to the base c. So this one we have gone. So from here to here, n power b is same. Agreed. So mix these two things. That is the first one and the third one, last one. So that will be 1 by n plus 1 to the power b log of n plus 1 to the base e to the power of c is less than the last one, 1 by n power b log n to the base e to the power of c. So this is un plus 1, this is un. Un plus 1 is less than un for all n belongs to n. That is the first condition of the Leibniz test. And further, limit n tends to by un is 0. Un is this one, limit n tends to infinity, b greater than or equal to 0, c greater than 0, therefore it is true. By Leibniz theorem, the series sigma n is equal to 3 to infinity -1 to the power of n by n power b log n to the base e to to the power of c is convergent when b greater than 0, c greater than 0. What happens when b is equal to 0? We consider in the second case. So this is convergent. For a is equal to minus 1, b greater than 0, c greater than 0. Now we consider b is equal to 0. Let b is equal to 0, c greater than 0. Then this series will be b is equal to 0. So n power b is 1. So you will get a power n by log n to the power c. And this is equal to n is equal to 3 to infinity minus 1 to the power of n into un. Alternating series, un is equal to 1 by log n to the base e to the power c is convergent. You can utilize again the Leibniz theorem. So in all these cases, that means n is equal to 3 to infinity a power n by n power b into log n to the base e to the power c is convergent if a is equal to minus 1, b greater than or equal to 0, c greater than 0. So we are looking for that series which is divergent. So option 4 is not true. Obviously, we have seen 1, 2 and 4 and they are all convergent. So option 3 must be true. But how? We will show you. So that means this time a is equal to 1, 1 greater than or equal to b greater than or equal to 0, c less than 1. We want to show that it is not convergent, so to speak, that it is divergent. So we have put a is equal to 1, so it is 1 by n power b log n to the base e to the power c. Now 1 greater than or equal to b greater than or equal to 0 is written as 0 less than or equal to b less than or equal to 1. Therefore n power 0 is less than or equal to n power b is less than or equal to n power 1, correct? Multiply throughout by log n to the base e to the power c, which is positive, therefore it will maintain the inequality, so you will get this one. Now write the reciprocals. 1 by log n to the base e to the power c is greater than or equal to 1 by n power b log n to the base e to the power c is greater than or equal to 1 by n log n to the base e to the power c. Now take this one and recall sigma n is equal to infinity 1 by n log n to the base e to the power p. This is a very well known series and whose result is we are utilizing here, is convergent if p greater than 1 and it is divergent when p less than or equal to 1. So in our case it is c. C is less than 1, if you take it is divergent. So now sigma n is equal to 3 to infinity 1 by n log n to the base e to the power c is divergent if c less than 1. So if you take c less than 1, it is divergent. So you are using comparison test here. You are using comparison test. By comparison test, this is so. So sigma n is equal to 3 to infinity 1 by n power b into log n to the base e to the power c is divergent if c less than 1. And for these values of b, we have already taken 0 less than or equal to b less than or equal to 1. So that means the series sigma n is equal to 3 to infinity a power n by n power b log n to the base e to the power c is divergent if a is equal to 1, 1 greater than or equal to b greater than or equal to 0, c less than 1. So this is not convergent. That's what we have to find out. So therefore the answer is the option 3 is true. True in the sense we have to find out that series which is not convergent. So the option 3 is true and the answer to this question is option 3. That is the detailed discussion of the solution of the problem from the section real analysis which is related to divergent series. I will add one line here. What you do in the examination may be entirely different. You will come out of the answer within no time by taking the particular values in that range, in the given range, and see and show that in each case of option 1, 2 and 4 it is convergent, and for some of the particular values that you consider under option 3, that you get a divergent series, and the answer you will get it within no time. that the answer is option 3. But our aim is in this is not that one. Our aim is to show as far as possible under those given conditions of the options 1 to 4, the series this series are convergent, and under option 3, under those conditions is divergent. As far as possible, we have taken the conditions in toto and tried to prove. Agreed. And that is the detailed discussion of the solution of the problem. And I am sure that you have understood the solution, and I wish you all the best. Thank you.